All right, welcome back. I've been having some trouble with the encoder, but I think we've got it working now. We've moved through the heat lectures. I want to walk you through a little bit of the information about the climate control lecture. There was a lot of stuff in here, and it's actually narrowed down quite a bit when it comes down to what you're going to be doing for the test. So I want to point you to that. We talked primarily about, this business of the difference between day-to-day weather and climate. We already mentioned that in one part of the review session. That certainly is on there. But like macro scale, mesoscale, and micro scale climates, interesting stuff. But again, in the interest of keeping the test from being like 200 questions, I had to thin it out. We talked about the different factors that affected the climate. They're all, they're all important, but some of them I'm not going to be asking you about. So I'm going to just steer you in the point of the review here to a handful of ones you do need to know. The most important factor is going to be the intensity of sunshine. Now, this is both about like the sun angle and the length of day that we did back when we did the heat stuff. So learning this as a separate thing is not so important, other than knowing that it is the most important factor that influences the climate of a location. If we scroll through these examples here, the second thing, which I do, this one is definitely on the test too, is about the importance of the distribution of land and water. Places that are close to bodies of water will have a milder climate than a place that's inland. Like, for example, when I did that lecture, we compared Seattle, which is on the Pacific coast, to Fargo, which is in North Dakota. These two places have very different climates, but they're at the same latitude. They get about the same amount of sunlight. And the reason why Fargo is so much more extreme has to do with the fact that it is far from an ocean. The ocean currents thing, I think I would push off until we do the oceanography test, even though we talked a little bit about it at this point. Prevailing winds won't be on the test. The positions of the highs and lows I threw out of the test. We won't have any more of those. Let's see, mountain barriers. Okay, mountain barriers are on the test too, but we kind of talked about it more in the terms of like how you bring air to saturation and how on the windward side of the mountain you get a very moist climate, and on the dry side or the downwind or leeward side of the mountain you had the rain shadow. So there's kind of multiple contexts you could be looking at that set of problems right there. I think altitude does make it on the test too. I think the idea of using altitude as a way of assessing what the climate was going to be like. Two locations that are at the same latitude and the same distance from the ocean, one will be colder if it's at a higher location than a place that is lower. I think that is all we do, because I think we threw out all this stuff at the end of this one about the Köppen-Geiger climate system. Now, I don't think there's any specific questions about the next lecture, which was that stuff about air parcels. I just wanted you to be able to talk about air parcels and use that term when we were doing humidity and stuff like that. But I do want to steer you towards a couple questions that come from the Nature of Air Lab. One key word that we will definitely be using on the test is mean free path. Remember, mean free path is on average how far a molecule goes before it hits another molecule. And at the temperatures and pressures near the Earth's surface, it's a very small distance. You computed it on your lab, and you got, 10 to the negative fifth meters or something. I mean, a tiny fraction of a millimeter. Air molecules barely move at all before they hit another air molecule. Whereas way up high in the but in the thermosphere or something like that, then the mean free path might be kilometers long, where it takes a very long time. These air molecules move very far before they hit anything else. So mean free path was an important concept that I know there's at least one question on the test. As far as what else comes from here, maybe some vague sense that like molecules are moving really fast, like maybe half the speed of sound or something like that. It's a couple hundred meters per second was the speeds you came up with. But that's all you really needed to know for that. If we move on and talk real quick, then we start doing what's the rest of this unit, which is moisture stuff. I'm just going to pull up this version of it. The first part was about phase transitions for water. The phases of water were solid, liquid, and gas. That wasn't such a hard thing. But these phase transitions, like melting and freezing, evaporation and condensation, sublimation and deposition, those guys are all over the test. There's quite a few questions about those guys. These specific properties here of water, like its density and its specific heat, did not make it to the final version of the test. But on the other hand, this business of like, what do we mean by freezing? What do we mean by melting? And what do we mean by, let's see here. Let me go and get some more of these guys here. This business of latent heat. I know latent heat did make it onto the test about how Well, you'll watch the video. I don't want to take up all your time on the review here. You don't do any problems though, like what's on the top of this slide here, where you're actually computing like how much heat is released by melting a gram of ice or anything like that. There aren't any problems like that on the test. We also had other phase transitions here. Again, I love looking at those questions here. How about evaporation and condensation? Do you remember how those processes worked and which ones were a warming process? They released heat into the environment. Which ones were a cooling process? They absorbed heat from the environment. Again, the actual numbers like 300 calories per gram is not what's important here. So we were gradually building this diagram here that was talking about latent heat release from the different phase transmissions. We also had the different big steps all the way from solid to gas, like sublimation and deposition. Frost was a good example of deposition. I know there's a question on the test either about frost or dew. So that would definitely be something to have reviewed. Sublimation is like how a frost-free refrigerator works, maybe how dry ice works, and so on. And so you had those processes. And so we built this huge diagram that was showing how ice changes to liquid water, changes to gas, and back and forth, and all the names of all these processes. Notice how the red ones were the ones that were absorbing heat. The blue ones were the ones that were releasing heat into the environment. Boy, if you could recreate that diagram for the test, you'd be solid on a whole bunch of the questions there. This is a big part of meteorology to understand how these different phase transitions to happen here. All right, and I think, again, it's always a good idea to review these questions that are packaged as part of those lectures. All right, I'm going to stop because I know this is getting close to running out of my time on this. Again, it's limited to 10 minutes per section. I think we'll do one more review section after this that is about the last parts of the moisture lectures.